Here's how to derive the coordinates that are always shown on a unit circle. These coordinates are for the angles of 30, 60, and 45 degrees. I never understood what made these angles so special so that all math students were required to memorize their coordinates. There are infinite number of angles available on a 360-degree circle. You don't just have 30, 60, and 45. We have 23 degrees, 27 degrees, 18.37582146 degrees. So yeah, I never knew why these three angles were so important that people needed to memorize the coordinates. I've heard that 60-degree triangles are pretty common for construction or engineering. And that's because when people are cutting the metal bars to weld them together to make triangles for trusses, you can just cut all the bars the same length. And then when you weld them together, you'll get a 60-degree equilateral triangle. But yeah, otherwise I don't know what makes these angles so special. I wonder if you could call these the Pythagorean angles, because all these angles are derived with Pythagorean theorem, so that makes them different. But I don't know if that makes them makes it worth memorizing their coordinates. An important thing to always do whenever you come across any information is to always ask why. So what would happen if you didn't do it? What would happen if people did not memorize these coordinates? For example, if someone didn't memorize the XY coordinates for 60 degrees, which are 1/2 and √3/2, what would happen then, and why couldn't they just look that up? I don't know. So yeah, I'm not making any statements, I'm just simply asking why. The reason I'm throwing in this tangent or this digression, I guess actually there's a couple of reasons. First off, a lot of my best and favorite teachers in school, college, graduate school, whatever, they always entertained us with a lot of tangential stories that were really fun and somewhat germane to the subject about which they were speaking. But as for this particular digression on memorizing, the problem with memorizing anything that you don't use, you'll very quickly forget it. So after you memorize these coordinates or these XY coordinates for 30, 60, and 45 degrees, 1 month after you take this class, you'll most likely not remember them. The significance of that fact is that's inefficient learning and inefficient education. In my profession, you'll immediately get buried with work if you're not extremely efficient, and basically you'll fail. So you always have to look at how to be more efficient. And if you memorize things that you're not going to use and then you immediately forget that information, then you should have used that time to learn more important things for your class or for your profession. Or you could have just used that time to watch TV and play video games, because in the end, you'll have the same amount of knowledge whether you memorize useless information or you just play video games. Another example of how memorizing useless information can go awry, I talked to a couple of beauticians that cut hair for a living. They both told me that in order to pass their classes and get certified and whatnot, they had to memorize all of the cranial nerves and what those nerves did and a bunch of information about them. So as for a beautician's job, if she's cutting down so deep that she has to worry about what cranial nerves she's cutting around, then she is cutting that hair way too short. Okay, so enough with the tangents, at least temporarily so, and on with the subject at hand. Okay, so unit circle, coordinates for 30, 60, and 45 degrees. First, I'll derive the XY coordinates for a 45-degree angle. What you do to derive the coordinates for all of these angles is you basically just keep rotating your triangles, and I'll show what I mean by that. You'll start with a triangle, and then you get the values for each side, and then you rotate it, and you'll get your answer. So let's start with a 45-degree angle here on 1/4 of our unit circle. Let's make the x-coordinate 1. And here's the secret to solving this puzzle. You also make the y-coordinate 1. This whole angle right here will have to be 90 degrees from here to there. I'll write that real quick. So this whole angle right here is 90 degrees. Let's find out what these two angles will equal. The interior angles of a triangle have to add up to 180 degrees. You can see my other videos for the proof on that if you want. So we have alpha plus 90 have to add up to 180 degrees. Therefore 2 alpha plus 90 will equal 180 degrees. The reason I know these two angles have to be the same is because the x-coordinate and the y-coordinate are the same, which makes it symmetric. So now we can use Pythagorean theorem since we know that the x-coordinate and the y-coordinate are both 1. So we have x² plus y² equals c². You can see the video I did on the proof of Pythagorean theorem if you're interested. 1 plus 1 equals c squared. C will equal the square root of 2. Therefore, this hypotenuse right here that connects these 2 points has a length of the square root of 2. And thus, if you cut this hypotenuse in half, you will have 1/2 of the square root of 2, which also equals root 2 over 2. By cutting this large triangle here in 2, we bisected it. Now we have a smaller triangle right here. Here's the 90-degree angle. Here's angle alpha. And the previous x-coordinate now becomes our hypotenuse. Or as they said in Key and Peele, I would like to be high on hypotenuse. So now we know that the hypotenuse is 1. The adjacent side to alpha is root 2 over 2. Let's flip this triangle around and put it on another unit circle so it'll look more familiar. We already know alpha is 45 degrees as I showed earlier, so here's our 45-degree angle. The hypotenuse is 1. The adjacent side is root 2 over 2. And since it's a 45-degree angle, that means it's symmetric, so that means the y-axis, or the y value, will also be root 2 over 2. So for 45 degrees, we get root 2 over 2, comma, root 2 over 2 for the xy coordinate. On the next page, I'll do 60 degrees because it's more logical to go in that order, to do 60 degrees first and then use 60 degrees to derive 30 degrees. I just found that out from playing around with this. And that's why I do this stuff and I do these videos. I found out these little nuances like this because if you just try to do 30 degrees first, it's just weird and hard. But when you start with 60 degrees and then go to 30 degrees, it becomes easy, and I'll show what I mean. So by sitting down and exploring these topics and just spending a long time looking at them and thinking about them, you realize things aren't always straightforward. Because if I just showed how to derive the 60-degree values first and then the 30-degree values, it would look like it wouldn't matter what order I went in, but it actually kind of does. So tricky little nuances here. Here's why a 60-degree angle is special and why I'm starting with it. Every side is equal. Make a triangle with each side equaling 1. Thus it's symmetric all the way around, so every angle has to be identical. And if we cut this symmetric triangle in half, then this value of 1 right here for the x-coordinate becomes 1/2. Alpha plus alpha plus alpha equals 3 alpha. That'll equal 180 degrees, so alpha has to equal 60 degrees. So now we know the x-coordinate is 1/2 because we just bisected our triangle. We know the hypotenuse is 1, so we can just use Pythagorean theorem to solve for the y-coordinate. 1/2 quantity squared plus y squared equals 1 squared. So y squared equals 3/4, then y will equal the quantity of 3/4, quantity to the 1/2 power, which is the same thing as root 3 over root 4, which is the same thing as root 3 over 2. So now notice with this box I drew right here, this rectangular box, the adjacent side to the angle right here at 60 degrees, that adjacent side is 1/2 because we bisected our triangle. And then the y-coordinate is root 3 over 2. To get the coordinates for the 30-degree angle, all we do is flip these, and that's because when you have a rectangular box right here, opposite angles will be identical. So if this is 60 degrees right here for alpha, this angle right up here would be 60 degrees, which means the angle next to it will be 30 degrees. So the adjacent leg of 60 degrees is 1/2, and the opposite leg, which is right here and right here, is root 3 over 2. Then we can take 30 degrees right here because you take 90 minus 60 to get 30. So the adjacent to 30 degrees will be root 3 over 2, and the opposite of 30 degrees, which will be right here, which also equals right here, that'll be 1/2, but I'll show that on the next page. By the way, the reason I started with 60 and then I went to 30 is because all of these line segments are 1. So I can use that to get my coordinates for 60 degrees, and then from that I can derive the coordinates for 30 degrees. Okay, next page. Here's the same triangle right here for 60 going up and then 30 right here. What I do now is just flip the triangle. Like I said at the beginning of the video, we just have to keep rotating these triangles. So now I rotate it down to where it's on its side right here so it looks more familiar. Now we have our 30-degree angle right here, and we know the adjacent leg of 30 degrees is root 3 over 2 as up here. And thus the opposite leg of a 30, in other words, the sine of 30 degrees, will equal 1/2. So cosine will equal root 3 over 2, and the sine will equal 1/2. In other words, those are your xy coordinates for 30 degrees. And that's it.